right, ladies and gentlemen, this is Mr. Anderson for Kellogg Community College to do part 2, or page 2, of the Chapter 8 test review. All right, so what we're going to do is take a look. This is actually a holdover from the previous page. This was basically solve using any method, and in fact, I think quadratic formula is probably going to be the best method to use here, but we do have to work a little bit to get it into that form. We have to move everything to the left-hand side to keep my x squared positive and set the equation equal to 0. It is possible that this problem is factorable. In fact, I know it is, but I will, in lieu of trying to do a tricky trinomial problem, I think it'd be better off if you and I just did the problem where we get a, b, and c, and then use the quadratic formula to do the rest of this. So a is 16, b is 24, c is 9. So negative 24 plus or minus the square root of 24 quantity squared minus 4 times a times c. All over to a. And so I will save you the time and effort when you compute the inside of this problem. You get the square root of 0, which is kind of nice. This is 32 in the denominator. So negative 24 plus or minus the square root of 0 is negative 24 over 32, which can be simplified by dividing the top and bottom by 12. So the answer is, multiplying the top and dividing the top and bottom by 8. Your answer is 3/4. And that is the only answer to the problem here. And again, this was a factorable problem. You may have remembered the trick. If the first term and last term is a square rootable number, this happens to be 4x plus 3, 4x plus 3, which set equal to 0. Any one of these set equal to 0 is going to give me the answer of 3/4. Subtracting 3 from both sides, 4x equals negative 3, dividing by 4, x equals negative 3/4. Again, I've shown you in this video on the other side in this one that, yeah, you can factor these problems as well as use quadratic formula, but on the test itself, there will be many more that can only be used with quadratic formula. All right, so for this problem, we are going to take a look at quadratic formula, but we first need to kind of manipulate our problem to do so. And I'll do so by subtracting 1 from both sides. So I got x squared plus 7x minus 1 equals 0, which means my a is 1, my b is 7, and my c is negative 1. Because there's no two numbers that multiply to make negative 1 and add to make 7. So what we have here is negative 7. Sorry, not negative 7. I'm sorry. Haha! It's a negative 7 plus or minus the square root of 7 squared minus 4 times 1 times negative 1. All divided by 2 times a. So you get negative 7 plus or minus the square root of 53 divided by 2. Now, here's where I would normally just write the problem, split up the wheels, negative 7 over 2 and the 53 over 2, just call it a day. But I'm going to want to use a calculator to approximate the solutions with rational numbers. So I'm going to use a calculator to turn that into a decimal. Now, to make this pretty much easy on myself, I'm going to have negative 7 plus the square root of 53. Type that in on the calc and hit enter, and then divide it by 2. And you'll get an answer rounded to 2 decimal places to be approximately 14/100ths. Negative 7 minus the square root of 53 divided by 2 is going to be approximately negative 7.14. So again, just typing this in, hitting enter, dividing by 2, and that'll give you what you need. All right, so let's move on to the next problem. This is an example of completing the square, but it says write it in perfect square trinomial form. You'll notice that this is not an equation. So what I'm looking for is that magic number. I'm looking for the magic number that goes right here. Now the equation for the magic number is taking the b, which is the number in front of the x coefficient, dividing it by 2 and then squaring it. Now if I take 18, divide it by 2 and square it, 18 divided by 2 is 9, and then 9 squared is going to be 81. So the magic number is 81. But we're not actually done with the problem because we need to complete the square and then write it as a perfect square trinomial in factored form. So this becomes x plus 9, and my final answer is going to be x plus 9 quantity squared, because it says write it as a perfect square trinomial in factored form. I like it in this case because we'll be using that in problem number 8, our last problem from this worksheet here on this page, because we're going to complete the square. And again, on this problem, you may only complete the square. You cannot use quadratic formula, so please make sure that you're using the correct technique. You're going to subtract 3 from both sides because we need to make room for the magic number. Okay. And now to complete the square, because this rectangle doesn't have the correct number here, we're going to take our 8, which is our b, and divide it by 2, which is 4, and square it, which is 16. So I'm going to put that magic number here and here, add 16 to both sides, maintaining the properties of algebra right there. And then I can rewrite that as x plus 4, x plus 4. I can rewrite this as 13. Now, x plus 4 and x plus 4 makes x plus 4 quantity squared equals 13. Take the square root of both sides, so we get x plus 4 is equal to the plus or minus of the square root of 13. Now, there's nothing we can do with the square root of 13. There's no way we can simplify it. Of course, in the test, you'll be looking for ways to do so, and if you have a negative number in here, you'll make sure to pull out the -1 and make it an I outside of the radical. Subtract 4 from both sides. X is equal to -4 plus or minus square root of 13. And that's the end of that. Thank you for watching.